Hello dear students, welcome to the third session of carbonyl compounds. In this session, we will continue the discussions of condensation reactions of carbonyl compounds. The next reaction of carbonyl compounds is aldol condensation. Aldehydes and ketones having alpha hydrogen atoms undergoes aldol condensation reaction in the presence of dilute alkali like sodium hydroxide, potassium hydroxide. Let us see what is alpha hydrogen atom. In this example, I have taken acetaldehyde. The carbon atom which is next to this aldehyde group is known as alpha carbon atom. If this carbon atom has hydrogen atom, those hydrogen atoms are known as alpha hydrogen atom. Acetaldehyde has 3 alpha hydrogen atoms. So, 2 molecules of acetaldehyde undergoes aldol condensation in the presence of dilute sodium hydroxide to give beta hydroxyaldehyde, which is popularly known as aldol. Why it is known as beta hydroxyaldehyde? Because this compound is containing hydroxyl group at the beta position. This is alpha position, this is beta position. So in the beta position there is hydroxyl group, and additionally this compound containing aldehyde group. So that's why this compound is known as beta hydroxyaldehyde, commonly known as aldol compound. Ketones also undergoes aldol condensation, which should contain alpha hydrogen atom. For example, 2 molecules of acetone, which is also containing 3 and 6 alpha hydrogen atoms. So this acetone also undergoes aldol condensation in the presence of sodium hydroxide to give beta hydroxy ketone. Alpha position, beta position, hydroxyl group at the beta position, and additionally contain keto group. That's why this is beta hydroxy ketone. Next we will see the mechanism of this aldol condensation. The mechanism of aldol condensation can be represented like this. In the first step, hydroxyl ion removes one of the proton from the alpha carbon atom to give carbanion. In the next step, this carbanion attacks another molecule of acetaldehyde at the carbonyl carbon atom and breaks the pi bond, and the electrons moves to the oxygen atom, leads to the formation of alkoxide ion. Alkoxide ion having negative charge on the oxygen atom. In the next step, this alkoxide ion gets the proton from the water molecule to form beta hydroxyaldehyde. That is the product of the aldol condensation. Next we will move on to the another reaction of carbonyl compounds, that is Perkin's reaction. The Perkin's reaction is aromatic aldehyde reacts with the acetic anhydride in the presence of sodium acetate followed by acid hydrolysis to give unsaturated carboxylic acid. Unsaturation means the compound which containing C double bond C. Additionally, this compound contains carboxylic group. So this is known as Perkin's reaction. For example, benzaldehyde, it's aromatic aldehyde, reacts with the acetic anhydride in the presence of sodium acetate followed by acid hydrolysis to give cinnamic acid, which containing carbon-carbon double bond and carboxylic group. Let us move on to the mechanism of Perkin's reaction. In the first step, the acetate ion, this is the acetate ion which abstracts a proton from the acetic anhydride to give a carbanion, that is carbon atom carrying negative charge. In the next step, this carbanion attacks the benzaldehyde at the carbonate carbon atom, and the pi bond breaks and the pi electrons moves over the oxygen atom to form alkoxide ion. This is the alkoxide ion. In the next step, this alkoxide ion gets the proton from solvent to form hydroxyl group. This hydroxyl containing compound undergoes dehydration, that is removal of water molecule, to form alkene. The water molecule formed by the hydroxyl group and one of the hydrogen atom. This hydrogen atom and this OH combines to form water molecule, results in the formation of alkene. So this alkene on hydrolysis, that is addition of water at this position C double bond O and O. So this bond breaks and water is added across this bond to form cinnamic acid and acetate ion. This is the mechanism of Perkin's reaction. Next we will move on to the another important reaction, that is Cannizzaro's reaction. Aldehydes which don't containing alpha hydrogen atom shows Cannizzaro's reaction. This reaction can be represented as like this: two molecules of aldehydes which do not containing alpha hydrogen atom undergoes self oxidation and reduction reaction in the presence of concentrated sodium hydroxide or potassium hydroxide, followed by hydrolysis, acid hydrolysis, to give one molecule of carboxylic acid and another molecule of alcohol. Two molecules of aldehyde, one molecule is oxidized to carboxylic acid and another molecule are reduced to alcohol. For example, here I have taken formaldehyde. This is the aldehyde which doesn't containing alpha hydrogen atom. There is no alpha carbon atom here. Two molecules of formaldehyde undergo self-oxidation and reduction in the presence of sodium hydroxide to give formic acid and methanol. Another example of Cannizzaro's reaction shown by benzaldehyde. This benzaldehyde also doesn't containing alpha hydrogen atom. This is alpha carbon atom, but there is no hydrogen atom. So benzaldehyde shows Cannizzaro's reaction. One molecule of benzaldehyde is oxidized to benzoic acid and another molecule is reduced to benzyl alcohol. Let us see the mechanism of this Cannizzaro's reaction. In the first step, the hydroxyl ion attacks the carbon atom of carbonyl group, and the pi electrons between carbon and oxygen moves to oxygen atom to form alkoxide ion. In the next step, the electrons on the oxygen atoms moves between carbon and oxygen atom to form carbon oxygen double bond, and hydrogen atom with electrons moves to the another molecule of benzaldehyde. This step is known as hydride transfer because H minus transfer from alkoxide ion to the benzaldehyde. This leads to the formation of benzoic acid and another alkoxide ion. So this alkoxide ion in the next step gets the proton from the solvent to form benzyl alcohol. That's all for this session. The references, and finally thank you for watching. See you in the next video of carbonyl compounds.